Alright, so we have in number 11 in section 1.4. The limit as x goes to negative 3 on the left of x over the square root of x squared minus 9. So, one thing that we might do, well, the first thing that we have to recognize is that the function's not defined between negative 3 and, excuse me, it should be not defined in the open interval between negative 3 and 3. Because if x is any value between negative 3 and 3, then the x squared minus 9 will end up being that the x squared term will be somewhere between 0 and 9. So therefore we'll get some number between 0 and 9 minus 9, so that'll end up being negative. So therefore the square root of a negative number becomes a complex number, and that's outside of our real number system, so therefore we say that it's not defined for values of x between negative 3 and 3. The reason that we say that is because when we try to graph it, if we try to graph any value between negative 3 and positive 3 on our graphing calculator, it just won't appear, right? So there's blank space between negative 3 and 3. When we graph this on our graphing calculator, we get a function that looks something like this, right? So this gives us a hint that probably the function has a vertical asymptote somewhere at negative 3. We don't know that for certain, though, until we take a look at this function a little bit. So we have the limit as x goes to negative 3 on the left of x over the square root of x squared minus 9, but we can factor x squared minus 9 into x plus 3 and x minus 3. One thing that we can do from here, right, is say the limit as x goes to negative 3 on the left. We can rationalize out this square root by multiplying the top and the bottom by square root of x plus 3 times x minus 3. And this gives us x square root of x plus 3, x minus 3, and on the bottom we have x plus 3 times x minus 3. We're assuming that we're taking all positive square roots and not negative square roots. So, if that's true, then we can see that there aren't any nice, easy cancellations that create removable discontinuities. There's no common factors here between anything. So we would say that there is a vertical asymptote at negative 3 and a vertical asymptote at positive 3. To recognize what's happening for x less than negative 3, remember we're approaching x on the left, so x is less than negative 3. So as x is less than negative 3, let's try and figure out whether or not it's diverging down to negative infinity or up to positive infinity. Probably the graph of the function indicates, hey, it's probably going down to negative infinity. But we can look at it and say, all right, well, we have probably a continuous quantity that's for values that are less. It's not going to be equal to 0 up here because this is only equal to 0 at negative 3, 0, and 3, right? So if it's negative, it's going to stay negative in this region that we're concerned with right here. So we have a number that's less than 3, so x is going to be negative. In our square root, x plus 3, that's going to end up being x is a number less than negative 3, so that's going to end up being negative. Negative 3 minus 3, that's also going to end up being negative. For the same reasons, these down here will also end up being negative as well. So let's figure out what happens to all these numbers, right? So we have negative and negative, we get square root of a positive number. We have a negative and negative on the bottom here. We have that becomes a positive, and we have a negative here. And we have square root of a positive number. Remember, we're taking all square root of positive numbers. And a negative number. And then finally, it's going to end up being negative over positive, which is negative. So this gives us a sign, right? We started off with this complex expression and just said, all right, well, all of these numbers are going to have signs to them, and we figure out what the end result will end up being. So we're always going to have a negative number, so this means that it diverges down to negative infinity. It's kind of a tricky question because it's not all that obvious as soon as you look at it. But that's number 11 from section 1.4.